All right, here we go. Chapter 10, AP Classroom Assignment. Number 1, a certain county has 1,000 farms. Corn is grown on 1,000 of these farms, but none of the others. In order to estimate the total farm acreage of corn in the country, that should be county probably. 2 plans are proposed. Plan 1, A, sample 20 farms at random. B, estimate the mean acreage of corn per farm in the confidence interval. C, multiply both ends by the interval by 1,000 to get an interval estimate of the total. Plan 2, identify 100 corn-growing farms. B, sample 20 of the corn-growing farms. C, estimate the mean acreage of corn for corn-growing farms in a confidence interval. D, multiply both ends of the interval by 100 to get an interval estimate of the total. We definitely want to use plan 2 because sampling 20 at random. The problem is that's out of the 1,000. And only 100 of them grow corn. So that's not going to help us. We don't know which one's there. So we definitely want to identify the 100 and then from that sample the 20 and then do a confidence interval and then multiply it by 100 on each end to get the idea of the total confidence interval for all 100 farms. You get an average per farm and then multiply that by 100 because there's 100 farms. So we definitely choose plan 2 over plan 1. Okay. A large city newspaper periodically reports the mean cost of dinner for 2 people at a restaurant in the city. Newspaper staff will collect data from a random sample of restaurants in the city and estimate the mean price using 90% confidence interval. In years past, the standard deviation has always been very close to $35. Assuming the population standard deviation is $35, which of the following is the minimum sample size needed to obtain a margin of error no more than $5? So margin of error, why did I do that? Margin of error is going to equal, why did I put 4? T star times S over the square root of n. And we're trying to solve for n. So our margin of error, they want to be no more than $5. One of the problems is when we did this with proportions, we knew what each was for T star, but we're not going to know that now. So we need to have a number for T star. We'll have a number for this. This is S is 35 over square root n. So we didn't really go over this, but I'm going to tell you what we're going to do. When you have to do this, when we're talking about a sample size and we need that critical value, and it used to be Z star, well now it's T star. The problem is we don't know what T star is because T star always depends on the sample size and we're trying to find the sample size. What we can do is use Z to give us a good estimate. So what we're going to do, if we know the numbers for Z, you can do it. We're going to do a normal, inverse normal. Our area should be what? 0.05 because it's 90%. So 10% left over and cut by half. So 1.64 is what we're going to use for our T star. So let's go back to this. So it's 1.64. And you're going to num solve this for n. But we're going to use that Z because it gives us a pretty decent estimate for what we need. There it is, numerical solve. And we got 5 equals 1.64. Get some little things in the way here. Control divide, times S was what, 35? And then control divide over the square root of n, comma n. We get about 131, and we'd want to round down, but I don't even know if that's going to be one of our answer choices. 133 is the closest. It's okay, we don't have to round down here, but because we're using this rough estimate for T, it's okay. 133 will do for us there. So 133. Weird bit of formatting here. Thank you, AP Classroom. It says a medical center conducted a study to investigate cholesterol levels in people who have had heart attacks. A random sample of 16 people was obtained from the names of all patients in the medical center who had a heart attack in the previous year. Of the people in the sample, the mean cholesterol level is 264.7 milligrams per deciliter, with a standard deviation of 42.12 milligrams per deciliter. So 264.7 and 42.12. Naturally, we have to go on to another page. Assuming all conditions for inference met, which of the following is a 90% confidence interval for the mean cholesterol level of all patients of the medical center who had a heart attack in the previous year. So straight up, we're doing confidence interval, 264.7 and 42.12. And we just got our numbers, so we do menu, statistics, confidence intervals, straight up T interval. And I've already forgotten my numbers. 264.7, was that right? 264.7, 42.12. 264.7 and 42.12. And naturally, I didn't even think to look at the sample size. What was it? 16. And they told us all this stuff has been met, so we're good with that. All the conditions, and they want a 90%. What? Hello. Why did it do that? What is it? 0.90. Why I put all that there? And so we get 246 to 283 about there. Is that one of our answer choices? 246, what did we say, 246 to 283? I think that was right. 246, 283. I'm already forgetting my numbers. So 246 to 283, right there. Okay, moving on to question 4. University that offers evening classes to a large number of students who commute to campus wants to estimate the mean commute time of all evening students. A parking facilities attendant selects one parking lot on campus, then selects the first 60 students who drive into the lot on a certain evening. Each of the 60 students is asked to provide their typical commute time to campus. The university will create a confidence interval for the mean commute time of evening students. Are the conditions of inference satisfied? Well, we don't have a random sample. They selected one parking lot, then the first 60. That's a good old convenient sample. So we're not selecting at random. Should be noted, by the way, we'll talk about this in class, that the random condition can also be met if they're talking about random assignment, if we're doing like a matched pairs or a two sample, as long as the randomness could also come from that, which gives us causation. But in this case, we only have one anyway, and they're just taking the first 60 students who drive on, and that's bad. No, students were not selected at random sample. Can't talk about all students. We couldn't even if we did random, we could only talk about, if they did random 60 students, we could only talk about that parking lot, not all the parking. Okay, question 5. When using a one sample T procedure to construct a confidence interval for the mean of a finite population, a condition is that the population size be at least 10 times the sample size. That's kind of reverse of the 10% condition. They're just saying, instead of saying the sample is 1/10 of the population, they're saying the population is 10 times the sample size. So they both mean the same thing. The reason for this condition is to ensure that we want independence, and it's not the sample size is large enough because we want a small enough sample size. Central limit theorem, no, is applicable. Simple, I mean having at least 30. Standard deviation is a good approximation of the population. Standard deviation, no, not really. Sampling method has nothing to do with bias. We're talking about dependence and independence. That it allows us, the difference between the dependence and independence is negligible and don't have to worry about Okay, a researcher conducted a 95% confidence interval for the mean number of alfalfa weevils in an alfalfa plant within a field. Based on 80 randomly selected alfalfa plants, researchers found an average of 2.5 alfalfa weevils per plant and computed 95% confidence interval would be from 1.5 to 3.5. Which of the following statements is correct interpretation of the 95% confidence level? So this is one we've been having a little bit of a problem with. It has nothing to do with 95% of the alfalfa fields. It has nothing to do with that. It has to do with that 95% always has to do with 95% of the confidence intervals created would capture the true population mean. So if we repeatedly sampled this field, taking samples of 80 plants and construct 95% confidence intervals, then 95% of these intervals would include 2.5. We don't know that. We don't know that they would include. 2.5 is not the population mean. We need to have the population mean. And the one that's wrong with this one, it would not include the sample mean, because the sample mean was 2.5. We don't know. Not all of them are going to. This is that thing where, like, here's the true mean. The first confidence interval was here. The second confidence interval was here. Another one's here. And on down the line. Well, occasionally one of them is going to miss. But for the most part, but this is not necessarily, like 2.5 could be right here. This could be 2.5. This is the true mean, and 95% of them, this is the population mean, and 95% of them, of the intervals we create from samples of size 80, will capture that true mean. Okay. Number 7, based on a random sample of 50 students, the 90% confidence interval for the mean amount of money students spend on a lunch at a certain high school is found to be $3.45 to $4.15. Which of the following statements is true? 90% of the time, the mean amount of money that students will be between. This is like saying 90% of the intervals are going to be the exact same interval. Obviously, that can't be true. We're going to get a different point estimate every time. 90% of all students, nope. That 90% has to do with the number of, the percentage of intervals that will capture the true mean. No, we would result in a sample mean. No, that doesn't even make sense. It would result in a sample mean amount of money being between there. No. We're talking about it's going to estimate the population. 90% of all random sample size 50 students obtained at this high school would result in a 90% confidence interval that contains the true mean. Yes. Oh, why did I write an X? Yes, that one's it right there. Was the last one. Approximately 45 of the 50 students the random sample will spend. No, there's that 90% thing again. 90% of the intervals will capture the true mean. We don't know what that is, and we would expect it to be between 345 and 415, but even that one could be wrong. But yeah, it's all about that. That's the percentage of intervals that would capture the true mean. Okay. A random sample of 50 students at a large high school resulted in 95% confidence interval for the mean number of hours sleep per day of 6.73 to 7.67. Which of the following statements best summarizes the meaning of this confidence interval? There again, I mean, 95% of all random samples of 50 would result in 95%. This is saying that 95% of the intervals would be exact same. No. 95% of all random samples of 50 students from this would result in a 95% confidence interval that covered the population mean for hours sleep per day. 95% of the students, no. 95% of the students, no. A student selected at random for 95% of the time. No, you're saying like there's a 95% chance of a random student being selected? No. So 95% of the intervals created would capture the true mean. Okay, number 9. A two-sided t-test for a population mean is conducted for the null hypothesis of mu equals 100. If a 90% t-interval is constructed from the same data, from the same sample and contains the value of 100, which of the following can be included about a test level of significance of 0.10? So if what they're saying is, let's see, construction of the same sample data contains the value 100. So if 100 is in your interval, this 90% and this 10%, this is like the significance level. Our p-value would be greater than that, basically. So the p-value is less than 10, no, because it's less than 10 would be outside of the interval. Outside of the interval. That's these. So no, it's 100 is inner interval. Now, so it's one of these two. It's greater than 10. There's not information. Nope, we have the information. So if our p-value is greater than 0.1, we fail to reject. So we should not reject. If it's less than that, that's when we reject. So that one's out. So there we go. Number 10, to determine whether an herbal supplement helps relieve knee pain, researchers will select 50 patients with knee pain to participate in the study. The participants will be randomly assigned to one of two groups, with 25 participants in each group. First group will receive the herbal supplement daily for 1 week. The second group will receive a placebo daily for 1 week. Patients will continue to take their current pain medication during the week. At the end of the week, the patients will record their pain on a scale of 1 to 10, where 1 represents no pain and 10 represents extreme pain. Assuming the conditions for inference have been met, which of the following would be most appropriate statistical method to estimate the difference in mean pain score between the herbal supplement and placebo for all patients? So we are doing, we can see, and probably from this test, the Z's are out. It's not proportions. So take out the Z's. Now we're talking about a herbal supplement group and a placebo group. You're not comparing. This one gets a little confusing. It sounds like you're comparing somebody to themselves. Like if that were within a group. Like if you took just the herbal supplement group and then had them rate their pain at the beginning and then at the end, and found the difference between that, and then went to the next person in the herbal supplement group and did that, that would be the match pairs. But in this case, we're comparing the herbal supplement group and the placebo group and checking that at the end. So it's not, well, it's obviously not, so it's not a one sample and it's not a match pairs because we're not comparing somebody to themselves. We're comparing two groups to each other. So that's a two sample. Okay. An owner of a novelty business operates both online store and retail store. The owner took a random sample of 50 sales from each store during the past year and recorded the purchase amount of each sale. Summary statistics are shown in the following table. Assuming the conditions for inference are met, the owner calculated a 95% confidence interval in mean purchase method online minus retail as 11.55 to 19.05. Following is an appropriate interpretation of the 95% confidence interval. Again, so this is the actual interpretation. We are 95% confident that, just saying it out loud, that the true difference in mean purchase amounts, online minus retail, is between 11.55 and 19.05. So which one comes up with that? We are 95% confident that the purchase amount from a randomly selected online store will be between 11.95 and greater than the purchase amount from randomly selected, or was it online minus retail? So what are my other choices? We are 95% confident that the sample, get rid of sample mean. Why did that do that? Get rid of sample mean, so we can do that. If new samples, the same sort of with the sample mean, purchase amount, no. Okay, we're 95% confident the population mean purchase amount, so this has to do with the randomly selected, no. We want the true difference, not having to do a random selection. We are 95% confident that the population mean purchase amount for the past year from both sales combined is between no. We're 95% confident the population mean purchase, the amount of phone store is between 11.55 and 19.05, greater than the population. Yes. The purchase amount, population mean purchase amount from the retail store for the past year. The whole thing's positive, so the first one's larger than the second one. Okay, sociologist was investigating the age difference, ages of grandparents and high school students. From a random sample of 10 high school students, the sociologist collected data on the current ages in years of students' maternal grandparents. The data is table below. Construct a 95% confidence interval. I'm not going to have a lot of room to do this, so we're just going to have to kind of talk about it. So choose for the population mean difference in age. So really all we're talking about is this. Okay? Hang on a second, I'm sorry. This is a good old paired one because we're averaging all this together. So this is a one prop or match pairs t-test or t-interval for the true, there's your mean difference in age of grandmother minus grandfather of the maternal grandparents of high school students, okay? So you do, I mean, we can throw this all in the calculator real quick again, right? So it's what, negative 1.8 and 5.81. So we're doing menu, statistics, and since it's a one sample, because we're talking about the mean difference, change to stats. Was it negative 1.8 and 5.81? And how many do we have? I don't even remember how many students did we have. Well, 10, okay. We got to talk about the conditions here in a second. 10, and do they want a 95%? I've already lost that. 95%, okay. So negative 5.96 to 2.36. So we can write that down. Negative. The only other thing we're going to need is T star, and our degrees of freedom is 9. So we can go back to the calculator and get that. Menu, statistics, distributions, inverse T. Our area is going to be 0.025, half of the leftover. Degrees of freedom is 9. So negative 2.26. So we got all the information we need. So that is 2.26. All right, so we have our first C, second C is conditions. First one is random, and from a random sample, the random is stated. We're going to assume 10 is less than 10% of all the students. And then we need to look at the data here and see, doesn't look like there's any skew. We don't have the central limit theorem. We're not told the distributions are normal. We have to look at both of them. All of them look roughly, there's a couple 55s, but then there's an 80, things like that. Looking at the mean is 70 or around 70 on both of them. There doesn't seem to be any strong skew or outliers with either of them, so that's fine. So then we have point estimate plus or minus margin of error, and our point estimate is negative 1.8. Just in case you want the regular one, it's X bar, diff plus or minus T star, S diff over square root of n. And so that's going to be negative 1.8 plus or minus what we found to be 2.26. And S diff is 5.81 over the square root of 10. And that gives us negative 5.96 to 2.36. So we have to conclude we are 95% confident that the true mean difference in age of grandmother minus grandmother, age of grandmother minus age of grandfather for these high school students is between negative 5.96 and 2.36. Now notice they don't actually ask us to then like draw a conclusion from that. Like this would tell us because 0 is in the interval, we have no evidence that there is a difference, a significant difference between them. So if they did ask you that, we have none. Is it true that the grandfathers are significantly older than the grandmothers? Well, no, we don't have any evidence of that. Okay, part B. One of the sociologists' research question was about the mean difference without regard to which grandparent is older. The interval constructed by RD does not address such a question. Based on the sample of high school, give the value of the point estimate for the mean difference in age that could be addressed to the sociologist's concern. So in other words, this is much simpler than you think. All you're going to do, they just want to know about the mean difference in age without regard. So this was always grandmother minus grandfather. We don't care which one's older. We just want to know the actual age difference. So we'd absolute value everything. And then you're going to add all these together, these 10 numbers together. Basically, you're going to do 1 plus 5 plus 10 plus 8 plus 3 plus 4 plus 4 plus 4, and then just simply divide that by 10. And I don't remember what you get offhand. I remember seeing it. Did I already miss it here? About 5.2 years. So our new point estimate would be 5.2 years. Okay, that was just, all you do is, you want just the age difference, not which one's older, so they just all become positive, then you have to add them up and divide by 10. Okay. Here it looks like a long one. Okay. Pharmaceutical company has developed a new drug to reduce cholesterol. Regulatory agency will recommend the new drug for use if there's convincing evidence the mean reduction in cholesterol level after 1 month is more than 20 milligrams per deciliter, because a mean reduction of this magnitude will be greater than the mean reduction for the current most widely used drug. Pharmaceutical company collected data giving new drug to a random sample of 50 people from the population with high cholesterol. The reduction in cholesterol level after 1 month use was recorded for each individual in the sample, resulting in a sample mean reduction in standard deviation of, so the mean was 24 milligrams and the standard deviation was 15 milligrams per deciliter. The regulatory agency decides to use an interval estimate for the population mean reduction in cholesterol level for the new drug. Provide a 95% confidence interval. Be sure to interpret this interval. So we still need to do the 4 C's here. So you got to state all the stuff. And this again is a one sample, because we're just given the 50 people and their difference. So, forgive me, get this done quick. You could just do a 1 sample, and we're 24 and 15. So menu, statistics, confidence intervals, t-interval, stats, okay. 24 and 16, was that right? Already lost it. See if I have it on this other page. 15, 24 and 15, my bad. And N was 50, and a confidence level of 95%. So 19 to 28, we need T star, statistics, distributions, inverse T, area is 0.025, degrees of freedom is 49, and it didn't work. Lovely. Menu, statistics, distributions, inverse T, area is 0.025, 49. So we get about negative 2.01. Okay. So our interval, I've already lost it. 19.7 to 28.3, and 2.01, 19.7 to 28.3, so 19.7 to 28.3, and T was 2.01. Could do the whole thing there. We should know how to do that by now. Interpret the interval. We're 95% confident the true mean difference in the new drug minus the old drug is, I'm sorry, this isn't even a difference. This is just the mean reduction of this new drug is between 19.7 and 28.3. Because the 95% confidence includes 20, the regulatory agency is not convinced the new drug would be better than sell it. The pharmaceutical company follows the hypothesis, where mu represents the population mean and reduction in cholesterol in the new drug. The test procedure is either a t-value of 1.89 and a p-value of 0.0033. Because p-value was less than 0.05, the company believes that there is convincing evidence of mean reduction of the explain why the confidence interval and the hypothesis set list led to different conclusions. So this one's a little funkier. So the 95% confidence interval, essentially the problem is you get the point on either side. So it's like this, you got 0.025 on either. It's like a two-sided test. But the p-value comes from a one-sided test. And so it's like half of that. So like the confidence, so let's see how they put it. Decision based on 95% confidence interval only corresponds to the two-sided test to the significance 5% level, not necessarily a one-sided test. The confidence interval in A is equivalent to testing mu 20 against mu not equals 20 instead of greater than 20. In this test, the tail probability would be doubled and the two-sided p-value of 0.066 would be larger than 5, failing to reject the null hypothesis. So like this only gives you the probability of not equal to instead of greater than. So that's why this is coming up a little different, okay? This basically you have to cut the p-value gets cut in half because we're talking about just the greater side. But if you compared it like to 0.025, so that's all it is. C, the company would like to determine the value of L that would allow them to make the following statement. We're doing this. So the value of L can be found using the following formula. L has the same formula as the lower endpoint of the confidence interval. So the idea is what value should be used for T star. The T distribution of, so now we'd have to change it, our T interval, to just a one-sided. And so T is going to use 49 degrees of freedom again, but now you just want the 97.5th percentile. And so you kind of cut this in half again, I believe, and you get 1.676. Basically, all this boils down to is you're just doing a one-sided. And I'm going to put this, let me see if I can do this real quick, on a separate page. I'll put their answers for C and D real quick. Okay, here's what they say for C and D. You can use that to talk about that because now I've already got to get to class. Okay, there you go. Good luck.